Dalton's law of partial pressure states that the total pressure of a gas mixture is the sum of partial pressures. This law is used to determine the individual pressures of each gas present in a combination of many gases. In an equation, this is stated as Pt is equal to P1 plus P2 plus P3. Pt is the total pressure, and P1, P2, and P3 are the amounts of partial pressures. Dalton's law actually has a key role in weather, especially when dealing with the atmosphere. The atmosphere is made up of water vapors, carbon dioxide, nitrogen, oxygen, and a small percentage of others. Add the partial pressure of each gas as you end up with the total atmospheric pressure. Boyle's law. Boyle's law explains the relationship between volume and pressure. The pressure exerted by a gas will change inversely with the volume. This means that pressure will increase if the volume decreases, and vice versa. This happens because gas is made up of loosely spaced particles that are randomly moving. So if you put a gas in a container and push the molecules together, the gas will decrease in volume. This will make molecules that now have less space to move bump into each other and the wall and will therefore exert more pressure. The equation for Boyle's law is P1 V1 equals P2 V2. P1 equals to the original pressure, P2 is the new pressure. V1 is the original volume and V2 is the new volume. Charles' law. Charles' law is a gas law that deals with gas, volume, and temperature. As Charles' law states, temperature in Kelvin and gas volume is directly proportional when the pressure is constant. In math terms, this would be stated as V1 over T1 is equal to V2 over T2. V is the volume and T is the temperature measured in Kelvin. As the temperature of a substance decreases, the molecules move slower, so forth hitting the walls of its container less. This causes the decrease in volume. Therefore, this proves that temperature decreases, volume decreases as well. As well as decrease in temperature, when the temperature of a substance is increased, the molecules move faster and the force is also increased. As a conclusion, as temperature rises, volume rises. Gay-Lussac's law. Gay-Lussac stated that pressure of a gas is directly proportional to the temperature if the gas volume is a constant, which means as temperature increases, pressure increases, and as temperature decreases, pressure also decreases. This is the equation of Gay-Lussac's law. P1 over T1 is equal to P2 over T2. P represents pressure and T represents temperature. This experiment shows how pressure and temperature are related. First, we set the candle in the dish. Next, we fill the dish with water and colored it. Then we lit the candle and used the beaker to cover on top. The beaker was filled with air molecules at the beginning. Air molecules gained energy from the flame as it was burning and rise the temperature. Because the air molecules became more active, we wanted to expand their volume. However, the volume was limited by the beaker. As molecules gained more energy and pressure from the high temperature, so the water inside the beaker was pressed down, and the water level inside got lower than the outside. When flame burned, it used oxygen to produce carbon dioxide and water vapor. They filled out to the top of the beaker and forced oxygen gas to lower, until the flame was extinguished. As the flame stopped burning, those air molecules started to drop in the temperature, and became less active. According to Gay-Lussac's law, the pressure decreases as temperature decreases. Because air inside the beaker wanted to be balanced and have the same pressure as outside, the air inside the beaker decreased its volume by pulling the water up. The pressure inside the beaker kept pulling the water into the beaker until the pressure was equal to outside. combined gas law. The combined gas law is a combination of Charles law, Boyle's law, and Gay-Lussac's law. This law states that the ratio between the pressure-volume product and the temperature of a system remains constant, which means that gas, volume, pressure, and temperature usually undergo changes simultaneously. Mathematically, this is stated as P1 times V1 over T1 is equal to P2 times V2 over T2. In this equation, P is known to be pressure, V to be the volume, and T to be the temperature. The last law is the ideal gas law. The ideal gas law is an equation for a hypothetical ideal gas. This law helps to show that all relations between four factors can be combined into one massive equation. In an equation, this will show as PV equals nRT. P is the pressure, V is the volume, N is the moles, R is the ideal gas law's constant, and T is the temperature. The ideal gas law's constant is 0.0821 atm times liters over moles times Kelvin. This means that if pressure increases, so will a factor on the other side of the equation, such as temperature, moles, or the ideal gas law constant. But the volume will decrease.